Okay, on chapter 14, set D number 4, we're told that a die is rolled 3 times and we want to find the chance of at least one ace. Now, anytime we're doing problems like this, we need to be thinking about like what outcomes would give us what we want. So if I'm going to list some outcomes. I'm going to say, use an A for ace and an N for not ace. So if I got like an ace first and then a not ace and a not ace, that would be at least one. Or what if I got an ace and a not ace and an ace? Well, that would be at least one. It would actually be two. What if I got like ace, ace, ace? That would be 3 aces, but that would technically be at least one. What if I did like ace, ace, not ace? That would give me at least one ace. Oh, but we could switch these around. I could do not ace, ace, not ace. I could do not ace, ace, ace. And you can tell there's quite a few different possibilities here. And I'm going to have to list out a lot of different outcomes for all of these. And I'm going to have to find the probability of each one. Like, so ace, not ace, not ace. So for an ace, that would be 1/6. And then I need a not ace. So that not ace would be like 5 out of 6. And then I need another not ace, and that would also be 5 out of 6. So I would have that probability of 0.11574. And I could do this next one. Well, an ace, that's always a probability of 1/6. Oh, I didn't even think about that. An ace on a dice means getting a 1. Getting something that looks like that with just one spot. So there's only one ace, and then there's 5 of everything else. So it'd be 5/6 for the not ace, and then another 1/6 for an ace. So we'd have 0.0231. And I'm going to have to do that for each of these, and I'm going to have to keep coming through, and it's going to kind of be a pain to do all of that. So this is what you'd have to do if you list out all of the possibilities. And this is only when we roll 3 times. If you want to roll for the other part 6 or 12 times, you're going to be doing this all day, and you're definitely going to miss some. Okay. We don't like to find the probability of at least one this way. Instead, we're going to use the complement rule. Anytime you see at least one, you're going to think, hey, I should use the complement rule. Okay? Because if you think about it, what is the only thing you can do that would not have at least one ace? The only thing without one ace, at least one ace, is if we get not ace and not ace and not ace. So it turns out that there are a lot of possibilities that have at least one ace, but there is only one possibility that doesn't have at least one ace. So the probability of at least one ace is going to be equal to 1 minus the probability of no aces, because that's just going to be a lot faster to find. Okay. And so every time it's at least one anything, you can just do 1 minus the probability of none. Okay, because that's always the opposite. If you want at least one, the opposite of that is none. So if we want to find 1 minus the probability of no aces, this will be 1 minus the probability. Okay, well, listen, how do you get no aces? For no aces, the only outcome for that is not ace and not ace and not ace. Let's see. So this will be 1 minus. Okay. What's the probability of not ace? If there's one side of the die that has a 1 or an ace, then that means there are 5 sides that do not. So for the first not ace, that will be 5/6. But then I need to get another not ace. Notice the and means multiply. So I need another not ace, so that would also be 5/6. The dice are independent, they don't affect each other, so each time it's just 5/6. And, so we do another multiply, we need another not ace. So it'll be 5/6, because again, if there's one ace on the dice, that means there's 5 not aces. So let's see, this will be 1 minus 0.5787. So this will be 0.4213. So that's how you use the complement rule. Okay, because you could try and do it the other way, but you have to list out so many possibilities, it's going to take you forever. So we use the complement rule. Let's try it for part B, and then you can try part C on your own. So it's the same, but now we have 6 rolls. So we'll say the probability of at least one ace is going to be equal to 1 minus the probability of none, or no aces. Well, let's see what that would entail. The only way I can get no aces is if the first one is not an ace, and the second one is not an ace, and the third one is not an ace, and the fourth one is not an ace, and the fifth one is not an ace, and the sixth one is not an ace. Now you'll notice when I say this, when I write this, I'm saying first is not an ace, and second is not an ace, and third is not an ace. And I don't actually write the first, second, and third, but that is always implied. It doesn't make a difference here, but it does make a difference when you're doing things that aren't independent. So even though I don't write first and second, third, that is always implied. So this will be 1 minus, okay, the probability of the first one being a not ace is going to be 5, 6. The probability of the next one not being an ace is going to be 5, 6. The next one is going to be 5, 6. And every one of these ends we multiply. The next one is not going to be 5, 6. And how many times do I have to do this? Well, 6 times, because I'm rolling the dice 6 times. If you want a faster way to put this in your calculator, you might notice this is 1 minus 5 sixths raised to the 6th power because I'm multiplying 6 times. You don't need to try and memorize this step to do the exponents. You can just write it out each time. So that's certainly going to be easier to try and remember, oh yeah, what was I supposed to do? So it's going to be 1 minus 0.3348. You'll notice because these are small decimals that I do like to round to a few more decimal places. So I get 0.6652. So that's the probability of at least one ace.